sklearnmetrics, mean absolute error. Description: mean absolute error (MA) is a regression metric that measures the average absolute difference between the predicted values and the actual values. It quantifies the average magnitude of errors in a set of predictions without considering their direction, positive or negative. Inputs: y true, the true target values, actual values. It should be a one-dimensional array or list. Y pred, the predicted target values generated by a regression model. It should have the same shape and data type as y true. Outputs: may a single floating point value representing the mean absolute error. Steps: calculate the absolute difference between each predicted value and its corresponding true value. Sum up all the absolute differences. Divide the sum by the total number of predictions to obtain the average absolute error. Metrics: MA is a simple and intuitive metric. Easy to understand. It is robust to outliers, as it focuses on the absolute magnitude of errors rather than their squares. It is scale dependent, meaning its value will change with the scale of the target variable. Visualization plots: scatter plot of predicted values vs true values, with a line representing the perfect prediction yx. The distance between points and this line visually represents the MA. Fine-tune parameters: none. MA is a simple metric without any tunable parameters. Uncertainty methods: confidence intervals for MA can be calculated using bootstrapping or other resampling techniques. Challenges and fixes: challenge 1: MA can be sensitive to the distribution of errors, particularly if the errors are not symmetrically distributed. Sample use case: a model predicting house prices might have a higher average error for expensive houses than for cheaper houses, leading to a higher overall MA. Fixes to challenge 1: consider using other metrics that are less sensitive to outliers or distribution of errors, such as mean squared error (MSE) or median absolute error (MED-AE). Transform the target variable, e.g., using logarithmic transformation to normalize the distribution of errors. Challenge 2: MA does not penalize larger errors as strongly as MSE. This can be an issue when large errors are particularly undesirable. Sample use case: a medical model predicting disease severity might suffer significantly from large errors, even if the average error is relatively low. Fixes to challenge 2: consider using MSE or other metrics that penalize larger errors more severely. Use a loss function during model training that prioritizes minimizing large errors, such as Huber loss or quantile loss.